Next topic in farming is sheet metal operations. Till now we have discussed farming operations only, but they are different. Like rolling is that is sheet metal only, but the thing is in forging, suppose if you take, it may be solid material. Okay, here it is not like that. Here sheet metal operations, thin sheets, it's not thick sheet. So but rolling is like working on thick sheet, converting into thin sheets. Sheet metal operations is operations performed on thin sheets to get the required shape of the component is called sheet metal operations. This is a very important chapter. Definitely 4 marks, 2 marks question definitely, sometimes 4 marks, 5 marks also you will get. Linked answer questions frequently they ask. Any operation, any type of mechanical operations performed on thin sheets to get required shape is called sheet metal operations. So, types of sheet metal operations majorly divided into two types: cutting and again here sheet metal forming operations. Sheet metal cutting, sheet metal forming. One is sheet metal cutting operations, another one is sheet metal forming operations. First we will discuss sheet metal cutting operations. So in sheet metal cutting operations again divided into two types. So before going to those in detail, so sheet metal cutting operations. So the name tells us that here we are doing cutting the sheet. That means if you want to cut any sheet, you need to apply a load more than ultimate stress. If you want to bend or if you want to change the shape of the dimension of a sheet, you need to apply load more than yield stress. So as from the stress strain diagram, which is very important, so this is yield point and this is ultimate stress. So these two are very important: yield stress, ultimate stress. If you apply a load above yield stress, it will go deformation takes place. You apply a load above ultimate stress, failure takes place, cutting takes place. In cutting operations, force applied on the sheet develops stress greater than ultimate stress. Force applied on thin sheet develops stress greater than ultimate stress. So ultimate greater than stress developed is greater than ultimate stress. So applied stress is greater than ultimate stress. So this is cutting operations. So here again two types. One is punching or piercing, making holes, punching or piercing. Another one is blanking, making blank pieces. So punching and blanking both are cutting process. These two processes are very important, and most of the people will get confused, and very simple to distinguish. Most of the times compulsory question in this. Most of the times 2 marks, 4 marks, minimum 1 mark definitely will be there. 3 marks is most probably. Sometimes we may get 5 marks also, just only punching and blanking. If you know this topic clearly, then you can get questions 2-3 marks. So here in punching and blanking, these both operations are similar. So first, if you take punching operation, suppose we will first write similarities. In both punching and blanking, so this is a punching, this is a die which supports the punching operation. This is the sheet, metallic sheet. So here we are applying load with punch. So this one is punch. This is thin sheet, metallic sheet. Here also. This is die, and whatever you will get here is blank. So keep the sheet on a die where there is a hole. So you apply a force by using punch. Because the sheet thickness is much more than the clearance between the punch and die. So there is clearance C between the punch and die. The clearance is C equal to clearance between punch and die. So if clearance is very small, then the sheet is, if clearance is more, then the sheet can bend and form a cup shape. That is called drawing, deep drawing or cup drawing. But here clearance is very less. It's 0.5% of thickness, 5% of thickness, less than 5% thickness. When the clearance is less than 5% or 10% of the thickness, it is less than thickness. So the sheet won't go and form the cup. So instead of that after some after some amount of load, the two layers parallel to the punch surface starts cutting. So that's why shear stresses, because of the surfaces, shear stress develops. Shear stress developed between punch and die. So the shear stress develops. Because of this shear stress, it suddenly failure takes place. So if the punch objective is to produce hole, that is called punching. Objective is produce blank, it is called blanking operation. So one by one we will go. The common in both punching and blanking, die is stationary, in both cases, and punch is moving always. So this is about one point, common point. And another point is die size is always greater than punch size. Punch has to go inside and create hole or some whatever. It has there has to be difference, space between the punch and die. It is called clearance. Because of clearance available, the punch size is less than the die size. So next, another point is both have same shape. Both punch and die will have same shape, geometry. If you want to produce a coin, it is called blanking operation, circular coin. So then you need to have circular punch and circular die. It's same way. In both, shearing and tearing is a mechanism. Mechanism is shearing and tearing. So that's about common aspect of punching and dyeing. T is equal to thickness of the sheet. C anyway we have discussed. Tau is shear stress, and D is diameter of the hole if it is in punching, or diameter of blank if it is in blanking. Depending upon the question, the D value changes. If you will go to one by one separately, punching, first topic. So we have discussed common points between punching and blanking, same shape punch and die, and punch die size is always greater than punch size. So and punch is moving, die is stationary. So what is punching? Punching is to produce holes on thin sheet. If you even you can produce holes on paper also, that is also called punching by using punch. There also if you observe, you will see the punch, small circular shape punch, and as well as die means supporting in whatever it is supporting downside, that is called die. So to produce holes on the thin sheet. In punching, size of the punch equal to size of the hole. Objective is you want to produce a hole of diameter 10 mm, then size of the punch you have to take is 10 mm. Size of the die equal to punch size plus or minus plus, because we have discussed that die size is always greater than punch size, plus 2 into clearance. C is clearance. Why 2 on both sides? So here by if you observe the above formula, in punching clearance is given to die. So this is about punching. And similarly for blanking next. So objective is to produce a blank so size of blank equal to size of not blank, size of die equal to size of blank. Size of punch equal to die size minus 2c. Here first what in problem how you can ask is, he will ask you the size of the blank produced. He will give size of the blank produced and he will ask the die or size of the punch. If you want to produce a blank of circular blank or coin shape component of diameter 10, so that is called die size is 10. So punch size is always less than die size, so you have to subtract clearance. So clearance in blanking is given to punch. So clearance in blanking is given to punch. That's what you have to remember, because in formula it is showing, right? So after this, go to the question number 21. Get 2002. One more question, and question number 22. Okay, first we will start question number 22, gate 2001. He has asked the cutting force in punching and blanking operations mainly depends on. So the cutting force we have discussed already. Cutting force in punching and blanking operations mainly depends on. I will read the options. Just keep a material with you, helps. So A is the modulus of elasticity of the material, B is shear strength of the material, C is bulk modulus of the material, D is yield strength. So modulus of elasticity related to linear stresses and bulk modulus is volumetric stress, yield strength is linear stress. So only shear strength is for shear stress. So answer is B. Answer is B, depends on shear strength of the material. Question number 21. Gate 2002. One more question. In blanking operation, the clearance is provided on. In blanking operation, the clearance is provided on where? As we have discussed blanking, we provide clearance on punch. Options he has given is A, die, B, both punch and die, C, the punch, D, brittle the punch nor the die. So answer is C, provided on punch. Next question is question number 19. Two 2003 2 marks question. A metal disc of 20 mm diameter is to be punched from a sheet of 2 mm thickness. The punch and die clearance is 3%. The required punch diameter is. So first, whatever he has given, a metal disc of 20 mm is to be punched. So operation is blanking. You want to produce a blank of 20 mm. Blanking operation, blank size equal to 20 mm. So a metal disc of 20 mm diameter is to produce, means it is a blank size. Sheet thickness T equal to 2 mm. Clearance is 3%. If we mention 3% means it's 3% of thickness always. that is equal to 3 by 100 into 2, 0.06 mm. Next, the punch diameter. So punch diameter equal to die size minus 2c equal to 20 minus 2 into 0.06 equal to 19.88. Answer is A. Simple. Force required in punching or blanking operation. Force equal to general formula is pressure into area or stress into area. Here stress is shear stress into area is shear stress develops between surface area. So AS equal to surface area. Tau is shear stress. Another way, F equal to tau into surface area is perimeter into thickness. P is equal to perimeter of sheet. T is thickness of the sheet. So for example, force required for square, circular punching, circular blank. Circular blank or punch, force required is this much. If it is rectangular means 2 into L plus B perimeter. You need to change that. Work done. Or energy required in punching or blanking. Work done is force into displacement. W equal to force into displacement. Displacement is how much the punch moves. So work done equal to force into K into thickness. K equal to percentage penetration into thickness. So for soft material the K is more because the penetration will be more. Penetration of the punch into the sheet before cutting. So here methods to reduce the punching force in the subtopic. So first method is providing shear. by providing